Hi folks, we're going to take a look at number 11 from page 139. Okay, so they ask us here is to find the x value so that the tangent to this particular curve is parallel to this given line. So remember that the tangent itself is a line, and in order for two lines to be parallel, they have to have the same slope. Okay, so the first thing I can do is find the slope of this line here, and the easiest way to do that is to just solve for y. Okay, so 16y equals negative x minus 3, and so y is equal to negative 1 over 16, x minus 3 over 16, but the only thing I'm really interested in here is that the slope is equal to negative 1 over 16. Okay, so we need to find the tangent lines that have a slope of negative 1 over 16. Okay, but in order to find the slope of a tangent line, that's just equivalent to finding the derivative of the function. Okay, so let's start by finding the derivative function for y, and then determining for what value or values the slope is equal to negative 1 over 16. Okay, now in order to take this derivative, I want to write it in a form that's easier to work with. And what I'd like to do is write this expression as a single power of x, so that I can use my differentiation rule. Okay, so I'm going to rewrite this as y equals 3 times. Now I'm going to need a negative exponent, and of course the cube root of x can also be written as exponent 1/3. Okay, so this allows me to use my derivative property to easily determine that derivative. So y prime is equal to, 3 is just a constant, so I can leave it out and then find the derivative of that expression. So here the negative 1/3 becomes our coefficient, and then the exponent will be reduced by 1. Okay, so negative 1/3 minus 1 is negative 4/3. Okay, and let's simplify this here. So 3 times 1/3 is 1, so here we have negative x to the negative 4/3. But remember, what we are looking for are the tangents that have a slope of negative 1 over 16. So I know I need my derivative to be equal to negative 1 over 16. Okay, and what this gives me now is an equation I can solve. Okay, so let's go ahead and do that. So negatives cancel each other out. Okay, so now I have to isolate x. So how can I do that? Well, I can take this to an exponent. So I'll need my exponent to be negative. So it becomes positive when I multiply it to negative 4/3. And what number can I multiply to negative 4/3? That'll give me 1. And that quite easily is just 3 over 4. Okay, so if I take the exponent negative 3 over 4 of the right hand side, I've isolated my x, so of course I need to do the same thing to the other side. So take the exponent negative 3 over 4 of the left hand side. Okay, so now I just have to use my exponent properties to simplify this number here. Okay, so this negative, no problem, that just gives me the reciprocal of the base. So instead of 1 over 16 to the negative 3 over 4, I can write that as 16 to the positive 3 over 4. Okay, and now we have to recall how to deal with fractional exponents. Okay, so I think of this as 16 being cubed and also to the exponent 1 over 4. Now the order in which I do these is not important, but I want to try to choose it wisely. So I have to ask myself, is it easier to first cube 16 and then find the 4th root, or is it easier to find the 4th root and then cube it? Okay, and that's where we try to keep in mind that for numbers bigger than 1, roots make the numbers smaller, whereas integer exponents make them larger. Okay, so I'd like to make my numbers smaller. So the first thing I want to do is take the 4th root of 16 and then cube it. That's certainly the easier way to go. Another thing we need to be careful of is we're taking a 4th root. Okay, so similar to when we take a square root, we realize that there's 2 possible scenarios. Okay, same thing for the 4th root. Okay, so this can either give us the 4th root, the positive 4th root of 16, or the negative 4th root of 16. So here x can be equal to positive 2 cubed, or x can be equal to negative 2 cubed. Okay, and this is because I'm taking this fourth root on the left side of the equation that I have to consider the two possibilities. So in the end, our two answers are 2 cubed is 8, or x equals negative 2 cubed, which is negative 8. Okay, so a lot of things we had to bring into play. So let's just do a quick recap. Okay, first of all, to realize that if I'm looking for a tangent line that's parallel, I need to compare the slopes. So I found the slope of my line, and then I use the derivative to find the slopes of the tangents. So once I have the tangent function, or the derivative function, I know that I need my slopes of tangents to be equal to negative 1 over 16, and from there I had to make use of my exponent properties to actually solve for x. Okay, that's it for this problem.